In this next exercise, we're also going to be dealing with parameters and variables in a method. And remember, a parameter is extra information that is passed along with the method and allowing it to do different things. For example, the say method would not be very flexible if it could only say one thing, if it only said hello. But because it has the parameter of what, you can pass an argument of look how high I can jump. You can pass the parameter of I can calculate hypotenuse lengths in my head, etc. So a parameter allows you to pass arguments, making the method much more flexible. So in this next exercise, our user story is that we have a fish that jumps out of the water, tracing a graceful arc through the air before re-entering the water. So we need to go ahead and start with a world with a water background. And if you look at the various classes of what the fish can do, the methods that are available to them, we do not have a jump method, so we'll be creating that jump method. And then in thinking about how we want to design that, you think of the different types of arguments you could pass to the jump method. One might be the distance you want the fish to jump, so it's different each time you call jump. It could be a little bit further, a little bit shorter distance, etc. Another possibility is height, and there is a difference because if you think of the high jump versus the long jump in the Olympics or track and field, they're very different behaviors. In this exercise, we're going to use distance as our argument that is passed. We'll have a parameter that holds that value, and the distance the fish jumps can be different each time the method is called. So let's start by adding our fish to the world. And there is a category called ocean. And we want the pink minnow, which is actually a minnow. It's very small. So this requires some careful placement. So drag him onto the screen, and he's going to be very tiny. So we're going to use the next to the last button, click it, and then click on the fish and drag to enlarge him so he's big enough for us to see. As for placement, you want him half submerged in the water. Obviously, we don't want him underwater because we won't see what happens. But rotate him so you can see the full length of his jump and have him submerged about halfway in the water. If necessary, you can move your camera away or move the fish closer or tilt the angle of the camera just so you'll be able to see the entire jump. All right, once he is situated, the textbook shows you a sketch of the different steps in this jump method we're going to create. And I've got a little screen capture of that here. So if you look, there are basically 6 steps. First, he swims forward a starting distance to get his speed up. And then he angles upwards in step 2. And these are labeled, they're numbered. Step 3, he moves upward the height of his jump as far as high as he's going to go and half of the distance, all the while angling upward. Step 4 is the second half of the jump out of the water, in which he's still moving forward, sorry, but he moves back down the amount he had moved up. So you have a certain height he's going to go up, and he'll go up to that at step 3, and then from step 4 he'll be going back down to water level. In step 5, he is going to angle upwards. In other words, he'll level off. And then step 6, he will swim forward a stopping distance. It's kind of gliding to a stop. So they have already plotted all of this out for us, and they've done the math. They have figured out, basic physics. We can, for the sake of simplicity, we'll approximate the height. However high he jumps is going to depend on how far he jumps. The further he jumps, the higher he'll go. If it's just a little short jump, if he's only jumping 1 meter, he's not going to go 6 meters in the air. It wouldn't make much sense. So we want those to be related. We also want the start-stop distance, how long it takes him to get up to speed and how long it takes him to coast to a stop, to also be related to how far he jumps. If he's only jumping 1 meter, he only needs a little bit of a running start. If he's making a 10-meter jump, he'll need to go further to get up to speed. So all of these are variables. These are numbers that will change depending on how far the distance is. So if you look at the sketch, you can see that we have got various different types of variables we'll need to create. We'll need to create one for step 1 and step 6. We'll call that start-stop distance, and they have decided that for simplicity's sake that we will make that 1/4 of the distance. So if he's jumping 20 meters, he's going to need 5 meters to get up to speed, and it'll take about 5 meters for him to coast to a stop. The height, how high he goes up in the air, will also be related to how far the distance is he's jumping, and they've decided that height will be 1/3 of the distance. And then finally in steps 2 and 5, you have an angle. That's just how much he'll tilt up out of the water before he jumps, and as he does step 3, and how much he'll tilt downward in step 4 and level off in step 5. So that's angle would be another variable. So it may seem complex, but they've done all the work for us. All we need to do is create these variables and the parameter of distance, and then use the various move and turn statements for each of these 6 stages of the jump. So we're going to go back to our Alice screen now and close the Add Objects window. This is something the fish can do, so select Pink Minnow and create a new method for him called Jump. And again, we want to pass the argument of distance, how far he's going to go, argument of 5 meters or 10 meters or 1 meter, etc. So that will be stored in a parameter we'll call distance. So each time he jumps, they're going to ask what the distance is, and that will make the method behave a little bit differently depending on what value you give that. So with the jump method created, create a new parameter we'll call distance. It will be a number this time. And again, there's no initial value because it's a parameter. The value is given when we actually call this jump method. Click OK. Okay, the variables we were talking about, we have to know how high he's going to jump. That's going to be 1/3 of whatever the distance is. We need to know the start-stop distance, how far he should go in order to lead up to get up to speed, and how long it takes him to slow down at the end. We'll create a variable for that called start-stop distance. It's the same number. Since there is, in step 3 and 4, let me look at this diagram again, he's going to be moving up for half of the jump and down for the other half of the jump. So we need to know what half of the distance is. So we can create do together statements in which he moves forward and up in step 3 and forward and down in step 4. So we'll have another variable called half dist. And then finally, we need a variable called angle, which is for steps 2 and 5, which is how much he tilts his body. So let's go ahead and create all these variables, and they're listed out for you. They've got a diagram of the variables and the single parameter you'll be creating in your book on page 86. And then they've also got the code, the finished code, in 86. So you're just following along with what the book has figured out for you. You don't have to do trial and error to figure out how much he should turn, how far he should go, and all of that. All right, so let's start creating these variables. The first one, let's create a new variable and call it height. It will be a number, and the value again will be 1/3 of whatever distance is. So we'll just leave the initial value at 1, and we'll be setting in the code. All right, create a second new variable, and we'll call that half dist, H-A-L-F, capital D-I-S-T, and that will be for the do together statements in step 3 when he's moving up half distance, and then step 4 he'll be moving down half distance. So that's also a number. Leave the value at 1. We'll be setting it in the code. Variable number 3, and make sure you're clicking create new variable, not new parameters. Everything except for distance should be below that line. All right, so we've got height, we've got half dist, start stop dist. That's steps 1 and 5 where he's getting up to speed and coasting to a stop. It's going to be the same value, so call it start stop dist. It is a number. Leave its initial value at 1. Click OK. And then our fourth and final one is the angle at which he rotates out of the water and then rotates back in step 5 to level off. And that is going to be a constant. It's going to be unchanging. So we can go ahead and set that in the dialog box. So create a fourth and final new variable, call it angle. It is a number, and we're going to have him rotate just 0.1%. So change the value right there in the dialog box to other 0.1. So 1/10 of a turn. Apologize again, my mother's dogs have not left my side. And they're very loud. Okay, all right, we've got all our variables and our parameters set up. Now it's time to set the values of these variables, and then we can just make the fish do its thing. So pull up a do in order, and let's start setting the value of variables. We decided that height is going to be 1/3 of the distance, so pull down height, choose set value, and we'll have to build it piece by piece because we're not typing this out in Notepad. We're having to do it with the Alice tools. So set the value to the expression distance. Everything is a portion of the distance. In this case, height is 1/3 of the distance. So set its initial value to distance, and then we can use the drop down arrow beside distance and then the math functions to divide. So we want distance divided by 3. So height is 1/3 of distance. If his jump is going to be 9 meters long, he'll go up 3 meters in the air during the course of it. All right, the second one we want to set is half distance or half dist. If you pull that down the code, we'll do the same thing. We'll set the value initially to the expression distance, and then we'll use the math tools to change it to distance divided by 2. Obviously, half dist. All right, and then the third and final one we have to set, because angle has already been set to 0.1 up top. The last one we have to set in the code is the start-stop dist, and they've decided that is 1/4 of the distance. So pull down start-stop dist, set the value to the expression distance, and then use the drop-down math tools to change that to distance divided by 4. All right, we have all our variables set. All we have to do now is do those 6 steps. Running up a speed, angling out of the water, moving up and forward while angling, moving down and forward while angling in the other directions to level out, and then coasting to a stop. All right, so in Alice, the first line of code that actually is action that makes the fish move will be pink minnow move. Drag that over under these variable setting lines, and we'll have him move forward, and the amount will be the expression start stop dist. So that is step 1. So we've gotten him that far in his jump. All right, and we're going to leave it the duration at the default 1 second. It'll take him 1 second to get up to speed. The next line is step 2. We want him to angle up out of the water. So to do that, we're going to use pink minnow turn method, which is directly below move. And we're going to have him turn backwards, so he's tilting his head up. He's turning backwards, and the expression will be angle revolutions. All right, and we don't want that to take a full second, because that would basically just pause the whole thing as he tilts up. That should be almost instantly that he tilts up as he starts the jump. So let's set a duration of, we can set it, the book has it at 0.1 meters, but you'll see the value of angle is 0.1. So you can either set it to 0.1 or you can set it to the expression angle seconds, which is 0.1. Either way, you can spell out 0.1 seconds or use angle seconds, which has a value of 0.1. That's up to you. And then we're going to be using, much like we did in the March, we want to set a style for this, so that as soon as that line of code executes, the next one begins immediately. There's no lagging, so it doesn't look jerky. So for that turn method, let's set more style and set that to begin and end abruptly. All right, that takes us through step 2. So now we're ready for him to actually begin the jump. We're going to do step 3. In step 3, 3 things are happening. He's moving forward, he's moving up, but he's also angling his body. And since we want all 3 of those things to happen at the same time, we need to pull up a do together statement. So pull that up right underneath the pink minnow turn. We're still inside of our original container do in order. And let's have those 3 things happen. First, we want pink minnow to move. This goes inside the do together. He'll be moving forward, and the amount will be the expression half dist. And we want a style of begin and end abruptly. Oh. All right, while he's moving forward, he's also moving up. So pink minnow move up, and the amount will be the expression height, to get us 1/3 of the distance. All right, and let's set the style on that as well as begin and end abruptly. All right, and the third and final thing he'll be doing in step 3 is he will be rotating his body. So we're going to have a pink minnow turn inside this do together statement. And he's going to turn forward, so he's tilting his head nose down a little bit, and the expression will be angle revolutions, 0.1 revolutions. All right, and the style is begin and end abruptly. So that's 3 lines of code inside of that do together statement. Do together statement, as always, is inside of our container do in order. Let me pull this up so you can see all of the code at once. So 3 lines of code setting the value of the variables. Pink minnow move forward, pink minnow turn backward, then a do together statement. That takes us through step 3. We're halfway through the jump now. Now we need him to move forward, move down, and angle his body again. So basically the same thing we had in step 3, except for he will be moving back down toward the water. So pull up a second do together statement. Make sure it is underneath the first do together, but still inside our container do in order. We don't want any code outside of that do in order. So the second do together statement will have pink minnow move forward, and the amount will be the expression half dist. At the same time, pink minnow will move down this time, and the expression will be height. It gets him back to water level. Both of those should have the style of begin and end abruptly. All right, and then the third and final thing is we want him to still have his body rotated. We don't want him to be level with the water as he moves around. He should look more natural by his nose turning up and down correctly. All right, so following the book, the third and final thing in the second do together is pink minnow turn. And the direction is going to be forward. He's still nosing toward the water, and the amount is the expression angle. And begin and end abruptly for that line as well. All right, so that takes us through step 4. Now we need him to level off before he coasts to a stop. So underneath the do together, but still inside the original container do in order, we'll have pink minnow turn. And this time he will be turning backward. And the amount will be angle revolutions, expression angle. And again, we don't want the whole jump to just pause in mid-jump while he tilts his head backward to level off with the water. So we're going to set a short duration for that. You can type out a duration of 0.1, or you can just use the expression angle, which already stores the value of 0.1. This should have a begin and end abruptly style. And then the final line of code that has gotten us leveled out in the water, we've done step 5, is step 6, where he coasts to a stop. So switching back to Alice, our last line of code will be pink minnow move forward, and the amount will be the expression stop start dist, which is 1/4 of the total distance. And finally, the style will be begin and end abruptly. All right, so to read through the code again, you've got a parameter of distance, variables for height, half dist, start stop dist, and angle. Angle is the only one that should already be set up top, and that is 0.1. If you have it wrong or need to change it, you can just click right here on the top row and set it. You don't need to create a new parameter, or create a new variable or pull it into the code. All right, so the code begins with our do in order. We set the value of height to 1/3 of distance, value of half dist to 1/2 of distance, and start stop is 1/4 of distance. Then the pink minnow moves forward, start stop. He turns backwards, angle revolutions for angle seconds, begin and end abruptly for all the rest of the lines of code. Then you have a do together statement in which the pink minnow moves forward half dist, pink minnow moves up height meters, and the pink minnow turns forward angle revolutions. Then another do together where he moves forward half disc, move down height meters, turn forward angle revolutions. And then the last two lines, steps 5 and 6, is pink minnow turn backwards angle revolutions. The duration should be angle seconds or 0.1 second. And the last one, he moves forward start stop disc meters, and there's no duration on this that I can see in the book. Okay, that's fine. The first one doesn't either, so it takes the default 1 second. All right, that is the whole code. Let's go ahead and test it by pulling over into my first method, this jump. And let's start with a small number. Let's have him jump 2 meters first and hit play to test it. You should see the entire arc. He should not spin around in the air, hit back in the water, and goes to a stop. All right, if I change the value of distance to something larger, he should go a further distance, jump higher, have a longer start, stop distance, etc., because they're all dependent on the length of distance. All right, and I couldn't see the whole thing there, so I'm going to move my camera back some so I can see more of his jump. Let me move it over this way a little bit. All right, test it again with 5 meters. So clear arc, and he coasts to a stop. All right, if you do have trouble with your minnow spinning around in midair or stopping, just review your code, make sure it matches exactly what you have on page 86 in your book. A lot of times students will get confused on the direction of the turns or not have their do together statements set up correctly. Make sure there are 2 different do together statements and each of them has 3 lines of code in there. All right, you're going to be saving this one as your last name, first initial, and then we'll call this jump and upload it to Moodle.